So if this is a rational root, this should always work out. The remainder should always be 0, and you should be left with a polynomial with 1 degree fewer, right? So if this were degree 4, now we have a degree 3 polynomial where the leading term is x cubed followed by, oops. Yeah, that's right, x cubed, right? 3 is 1 fewer than 4, x squared plus 1x minus 6. Okay, so here's our new polynomial. Now we're going to do the same thing over, except this time we're going to divide by this. Will be our divisor, okay? And you're going to do this for however many times you have a 0 or a rational root, okay? So let's do this again. This time we cannot use synthetic division because we have this form. Well, we could, but it's easier, right, to have a divisor in this form. We don't have that divisor this time, so let's use long division, okay? Take your quotient, and we're going to divide that by 2x minus 3. Okay, 2x minus 3. We're going to divide it into this polynomial, 2x cubed minus x squared plus x plus 1x. I'm just going to write plus x minus 6. Okay? All right, first and foremost, let's go ahead and identify what number or what variable expression do we multiply 2x by to get 2x cubed. We got to multiply by x squared. Okay? So I'm going to put that right here, x squared. X squared times 2x is 2x cubed. X squared times negative 3. No, that's negative 3x squared. Okay? We're going to flip the signs and then add through. Flip the sign and add all the way through. Those terms are opposites. You're left with negative x squared plus 3x squared. Okay, if you have 3x squareds and you owe me, this is 1x squared. Well, you're going to have, at the end of the day, you have left 2x squareds. Okay? Let's go ahead and bring down the next expression, or next term in this polynomial expression. We have plus x. And we're going to do the same thing. Okay? What expression, what variable term, what number do we multiply 2x by to get 2x squared? We're going to multiply by x. Okay? X times 2x is, go ahead and write this, 2x squared. X times negative 3, that's negative 3x. Flip the signs and add through. In other words, we're adding the opposites, or we're subtracting. Okay, so minus, plus, add through. These are opposites. These terms cancel. We're left with x plus 3x. Well, this is 4x. Bring down the last term, 6, or negative 6. And we'll do it all again. What number multiplies by positive 2x? What variable multiplies by positive 2x to get us positive 4x? Well, that's 2. Positive 2. Positive 2 times 2 is positive 4x. 2 times negative 3, that's negative 6. Uh-oh, this is really nice. We're going to get no remainder, okay? We're going to subtract our expression, flip the signs, and add through. 4x minus 4x is 0. Negative 6 plus 6 is also 0, so our remainder is 0. Okay? So what this means is, essentially, okay, this here, this remainder, or this quotient, is going to multiply by this linear factor and this linear factor for us to obtain this polynomial. Okay, so this times this will equal this expression here, this polynomial. Okay, so what this means is this 0, this linear factor will produce this 0, negative 1. This linear factor will produce this 0, 3 halves. But what root does this quadratic equation, quadratic expression, quadratic polynomial, what 0 does this produce? Well, if we go back to here, I'm going to move this around, see if we can. Oops, don't do that. Let's see if I can move just this layer. Okay, if we move this around, you'll see that we're only expecting 2, okay? This 0 and this 0. So that means whatever the zeros that are created by this quadratic, okay, when we solve for x to identify what values of x make this expression equal to 0, is not going to exist in the real number system, okay? We're going to find that we're going to find a complex root, okay? So let's do it. Let's just apply the quadratic formula and see what do we get, okay? Again, this was steps 2 and 3. Steps 2 and 3, we did all the synthetic or log division, and now with the remaining quadratic factors or remaining factors, okay, we're going to use some additional factoring methods to simplify. Unfortunately, there's no other methods we can use to simplify unless we were to use completing the square, okay. But let's apply the quadratic equation, okay. I think this would be a little bit easier. You know what, I could probably do another video, or even in class we can go ahead and use completing the square to finish this up. Okay, let's go ahead and do it. Let's use the quadratic formula. So the quadratic formula says that x, okay, the values of x that make this quadratic equal to 0 are going to be equal to negative b plus or minus the square root of b squared minus 4 times a times c all over 2a, where a, b, and c are the leading or the coefficients of this polynomial. Okay, what are the coefficients? Let me see if I can get it in a nice color. Nice bright red would be great. Okay, the leading coefficients are 1, and 2. Okay, 1, 1, and 2. A, B, C. 1, 1, 2. We just gotta plug and chug, guys. Let's evaluate. Okay, 1, 1, 2. So we have negative 1 plus or minus the square root of 1 squared minus 4 times 1 times, remember, c is 2, times 2, all over 2 times 1. Let's simplify. 1 squared is 1, 4 times 2 is 8, 1 minus 8 is negative 7, so we're left with negative 1 plus or minus the square root of negative 7, all over 2 times 1 is 2. This last step, can we simplify? Sure. 7 is prime, but the square root of a negative is the imaginary unit I, okay? So we can rewrite this as, remember this is x, negative 1 plus or minus I root 7 all over 2, okay? And there's all our zeros. Our zeros are negative 1, 3 halves, and negative 1 plus or minus I root 7 over 2, okay?